Welcome to this video. In the previous video, we understood the experimental probability. Today, we will understand the theoretical view of probability. Joseph is going to his friend Webber's house. The road on which he is walking further gets divided into two roads. Joseph starts looking for a signboard in order to find the right direction. Joseph's walk on the road is a trial. Now, can you tell the outcome of this trial? We can say that both the roads in front of Joseph are outcomes for this event. Let's represent the road on the left as X and the road on the right as Y. As Joseph is not able to find any signboard on the road, we can say that the possibility of either road being the right one is 50%. Why did we make such a prediction? Because we don't know yet as to which of these two roads is the right one. Therefore, we cannot be biased towards any of the two roads, and hence, the possibility of either road being the right one has been assumed to be 50%. You can see that like every time, we are saying possibility. And when we are talking about the possibility, then we have to understand that we are talking about probability, which we represent by P. We can see that here we have no previous data to choose the right path, due to which the experimental probability cannot be used here. In such situations, we take the help of theoretical probability, which is also known as theoretical or classical probability. We use this formula to find the value in numerical form. In this position of Joseph, we have a total of two outcomes. If Joseph chooses road X, then the number of favorable outcomes will be 1. Similarly, choosing road Y will have the same number of favorable outcomes, that is 1. From this formula of theoretical probability, the probability of choosing both roads is 1 upon 2. Here, the probability or possibility for both roads is the same. So we call them equally likely outcomes. If we had 3 roads here instead of 2, can you tell us the probability for them? When there are 3 roads, the total number of possible outcomes becomes 3. And as before, the number of favorable results for each road will be 1. Therefore, the probability of each being correct for the 3 roads will be 1/3. Because this time also, the probability is the same for all the 3 roads. So we can also call them the equally likely outcome. Can you think of a situation in which the result is not equally likely? No? Never mind. Let's think together. Suppose Joseph has 7 balls in this bag, including 4 red, 2 blue, and 1 black ball. If Joseph had to put out a ball without looking inside the bag, can you tell us what the results will be? Will the results be equally likely for all 3 balls? Due to a large number of red balls, it is most likely to come out. Similarly, the probability of the blue ball coming out is less than the red ball and more than the black ball. And the black ball will be the least likely. You can see that the probability of the 3 balls coming out here is different. Therefore, the results will not be equally likely. Let's understand one more important thing. If we add the probabilities to the condition of the 2 paths, we get 1. Similarly, you can see that in the case of 3 paths and balls, 1 gets 1 by adding the probability. Therefore, we can say that by adding all probabilities of an event, always we get 1. But how is this possible? Let's see. If we have only one road, then we have no other choice. Therefore, the probability of walking on that path is 100%, or you can say that the probability is 1. So we can say that this event is a sure event. After moving ahead, the road is divided into more than one road, and then probability also gets divided accordingly. Therefore, adding these divisible probabilities always gives 1. Let's come back to our first position. Joseph was just choosing the right path. Until then, a friend of his, Mohsin, comes there, who tells him that road Y is the right way. In such a situation, the probability for road X changes to 0, and that of road Y becomes 100%. Because now we know which is the right path. So walking on road Y is a sure event. Therefore, the event which is sure to happen is called the sure event. It has 1 probability. Conversely, the probability of an event that is impossible to happen is always 0. Such an event is called an impossible event. For example, after finding the right path here, Joseph will not go on the road X. So it is an impossible event. Based on this, we can say that the maximum limit of probability of an event will be 1 and the minimum limit will be 0. Now that Joseph knows he has to go to road Y, it means that he will no longer go to road X. In such a situation, walking on road Y and walking on road X will be a complementary event, which we show with E bar. Can you tell me how you can find the probability of a complementary event? We know that the total probability is 1, from which if we subtract the probability of the event occurring or happening, then we get the probability of the complementary event. If we again look at the situation where the probability of choosing road X is 1 upon 2, then we can find the probability of choosing road Y, which is shown as follows. Hopefully now you have got a good understanding of probability. Today we looked at probability from a theoretical point of view for an event. To find the theoretical probability, equally likely result, sure event, impossible event, complementary event, limit of probability, and the sum of probabilities.